Glenda, Helga, Iona, Julia, Carl, and Lou participated in the 2017 Canadian Team Math Contest. On their team uniforms, each had a different number chosen from the list 11, 12, 13, 14, 15, 16. Helga's and Julia's numbers were even, Carl and Lou's numbers were prime, and Glenda's number was a perfect square. What was Iona's number? Okay, Glenda's number is a perfect square, so obviously the only perfect square is 16 from this list. So Glenda is 16. The number. Carl and Lou's numbers were prime. The only prime numbers are 11 and 13. So we can assign those to Carl and Lou. There we go. Then Helga and Julia's numbers are even, so the only even numbers left are 12 and 14. So Helga and Julia will get 12 and 14. And the only number left is 15, so that must be the number for Iona. Number 12, the answer is D. In the diagram, each of the numbers 0 through 7 is to be used to label a vertex of the cube. The numbers 0, 2, and 3 are placed as shown. The sum of the numbers at the ends of each edge must be a prime number. Note, 1 is not a prime number. The value of m plus p plus q must be. Let's experiment with this. First and foremost, I'll write out the numbers 0, 1, 2, 3, 4, 5, 6, 7. And immediately we will get rid of the numbers they've already placed, which are 0, 3, and 2. Those numbers have already been accounted for. All right, so let's see what we can do here. The numbers along any edge must add up to become prime number, right? The sum of the numbers at the ends of edges must be a prime number. All right, so let's see what we can do. Wherever you'd like to start, I'm going to start right here with R, since it's at the bottom. 0 plus R must be a prime number. Okay, so what can R be? Can R be 1? No, because 0 plus 1 is 1, and 1 is not a prime. 0 plus 4? Nope. 0 plus 5? Yeah, 5 is a possibility. That would work. 0 plus 6? No. 0 plus 7? 7 is also a possibility. So for R, it can be either 5 or 7. Now if it's 5, 5 plus 2 would be 7, and that would work. But if it's 7, 7 plus 2 is 9. That would not work. So therefore, R must be 5. So there we go. We got R. Now let's concentrate on the top right here. Well, I've got R, so I might as well just work with R. I mean, you can do this in any order you'd like. It doesn't really matter. Or you can go with Q or P. So whatever. I'll just go with Q since I like the smaller numbers. Makes it easier for me. 3 plus Q has to be a prime. So let's see what I have left. I've got 1 left. If I put 1, that doesn't work. 1 plus 3 is 4. If I put 4, 4 plus 3 is 7. That does work. If I put 6, 3 plus 6 is 9. That does not work. And if I put 7, 7 plus 3 is 10. That does not work. The only one that works for Q is 4. All right, great. Let's keep going. Let's try P now. With the numbers that are remaining, 2 plus 1, that would work. That is a prime. 2 plus 6 is 8. That does not work. And 2 plus 7 is 9. That does not work. So P must be equal to 1. All right, great. How about N now? Let's see. 1 plus 6 is equal to 7. That would work. And 1 plus 7 is 8. So this must be a 6. And then basically, by process of elimination, that is 7. So now let's figure out the value of M plus N plus P plus Q. That is going to be 7 plus 6 plus 1 plus 4. And that is equal to 13 plus 5, which is 18. So number 13, the answer is 18, which is choice C. 503 is a prime number. How many positive integer factors of 2012 are there? Well, 2012 is equal to 4 times 503. So it's nice that they told you that's a prime number. Well, this is really just 2 times 503. And you can also write that as 2 to the power of 2 times 503 to the power of 1. Now, anytime you have this kind of a scenario, you have two choices. You can list them manually, and if there's not that many of them, it wouldn't take you that long. But if you had a large number like 7 times 503 to the power of 12, then obviously it would be very long. There's a trick. What you do is you take this number and you add 1 to it. So in this case, it'd be 1 like that. Then you take this one and you add 1 to it. And then you multiply them. So in this case, it would be 3 times 2, which is 6, right? So it would be very easy to do something like that with this technique. Manually, it would take forever. But let's do it manually also. I've got 6, so I've got to find 6 of these. Okay, no problem. One factor is just the number 1 itself. One factor is just 2012 itself. And then, of course, 2 is a factor, 4 is a factor, right? 503 is a factor, and 503 times 2, which is 1006, is also a factor. So 1, 2, 3, 4, 5, 6. So with both techniques, that one and the manual one, I got 6 factors. So number 16, the answer is D. On each spin of the spinner shown, the arrow is equally likely to stop on any one of those 4 numbers. Deanna spins the arrow on the spinner twice. She multiplies together the 2 numbers on which the arrow stops. Which product is most likely to occur? Well, the first time you spin it, it's got to have any of those 4 numbers. And the second time you spin it, again, it's going to have any of those 4 numbers. So there's a total of 4 times 4, 16 possible outcomes in terms of the 2 numbers that will result. So since there's 16, which isn't really that many, I can write them all out. So the first one, 1, 1, 1, then 1, 2, 3, 4. If the first time it lands on 2, the next time it could land on 1, 2, 3, 4. And similarly, right? 3, 3, 3, 3, 1, 2, 3, 4. And then the last one is 4, 4, 4, 4, 1, 2, 3, 4. So these are the outcomes, 16 of them. Now what I'm going to do is for each, write the product, because we're multiplying those 2 numbers and then looking at what do we get. So this is 1, 2, 3, 4. 2, 4, 6, 8. 3, 6, 9, 12. 4, 8, 12, and 16. Now, of these products, they're saying which one is the most common. Well, looking through this list, it looks like 4 appears 3 times, and I don't think any other product appears 3 times. A lot of them appear twice, but I think 4 is the only one that appears 3 times. So that's that's the product that's most likely to occur. So number 19, the answer is 4. The number 2018 has exactly 2 divisors that are prime numbers. The sum of these 2 prime numbers is 2018, when you break it up into its prime factors, is 2 times 1009. 2 is a prime, and 1009 is a prime number. They want you to add these 2 because they want the sum. So 2 plus 1009, and that is, of course, 1011. So number 14, the answer is B. A circular spinner is divided into 8 equal sections as shown. An arrow is attached to the center of the spinner. The arrow is spun once. What is the probability that the arrow stops in a section containing a prime number that is odd? So we want prime numbers that are odd. All right, let's circle them. 2 is a prime number, but interestingly, it's the only prime number that's even. 3 is a prime that's odd. 4 is not a prime. 5 is a prime that's odd. Well, every prime number is odd after 2. 6 is even. 7 is a prime. 8 is even. 9 is not a prime. So of those 8, only 3 are prime and odd, and there's 8 of them in total, so the probability is 3 over 8. Number 14, the answer is C. A positive integer larger than 2 is called composite if it is not prime. What is the smallest prime number? That is the sum of 3 different composite numbers. Let's list some numbers here, 2, 3, 4, 5, 6, 7, and our answer choices are going up to 23, so I don't think we need to go farther than 23. Let's see what we get. Maybe we'll get it pretty quickly. First and foremost, we are only interested in composite numbers, so I can immediately cross off the primes. That's prime, 5 is prime, 7 is prime, 11, 13, 17, 19, and 23. All right, so from the remaining numbers, I've got to choose 3 different numbers and add them up to get a prime number. All right, let's see. Let's obviously start with the smallest ones because they want the smallest prime number. So 4, 6, and 8 are my smallest remaining composite numbers. 4 plus 6 plus 8 is 18, but 18 is not a prime. It's divisible by 2. It's an even number. Okay, no problem. Go back to the drawing board. Let's try 4, 6, and 9. 4 plus 6 plus 9 is 19, and 19 is a prime number. And there you go, that's it. So number 14, the answer is D. The sum of 2 different prime numbers is 10. The product of these 2 numbers is. Well, let's just list the prime numbers that are below 10. And there you go. Those are the only 4. So 2 of these, when you add them, equals 10. And obviously that's got to be 3 plus 7. Now, those are my prime numbers in this question. Now I have to find their product. So I have to find 3 times 7, and that is 21. So number 13, the answer is B. 2 different prime numbers, and that n is equal to p squared times q squared. The number of possible values of n with n less than 1,000 is. Well, let's make a table and see what we get. And we, of course, have to pay close attention to the restrictions, which are n is less than 1,000. Okay, what are our prime numbers, first of all? Let's just make a quick list. 2, 3, 5, 7, 11, 13, 17, 19. I'm pretty confident we won't have to go farther than that. Okay, so let's make the list. We have n, p, and q. So n is equal to p squared times q squared. So let's start with the smallest, when p is 2, and they have to be different. Okay, so 3. If I do that, I get 36. How about 2 and 5? That will give me 100. 2 and 7, 196. 2 and 11 would give me 484. 2 and 13 would give me 676. 2 and 17 would give me 1156. Oh, okay. So at this point, that's not good because n has got to be less than 1,000. So I've exhausted the 2's. So that's done. So let's move on. 3's this time. 3, 2 has already been chosen up here. So that's already been done. So let's try 3, 5. 3, 5 would give me 225. 3, 7. Let's try that one. That's 441. 3, 11. 3, 11 is going to be 1089, and that is invalid because it's not within our range. Okay, so the 3's are done. Now let's move on to 5, obviously. 5, 2 and 3 are already been done, so let's try 5 and 7. That's 1, 2, 2, 5. So immediately that doesn't work. So I think we've exhausted everything. So how many did I get? 1, 2, 3, 4, 5, 6, 7. So 7 possible values of n, number 17. Therefore, the answer is E.